so I'm going to get right into it. First, we're going to start with measuring biomass. This is a topic on energy transfers, but I'm just going to be focusing from ecosystems to the food chain, but I'm not going to go completely into it, just the parts I found the most difficult. So if you think I've missed anything or you want me to go into greater detail explaining something, please just write it down in the comments. I will upload a video of that too. This is mainly a channel for me to teach to myself basically how to revise these things. I'm gonna get right into it with ecosystems. You need to know this keyword. So ecosystems are a community of living organisms in conjunction with non-living components of their environment. So the non-living bit, that means abiotic factors like temperature, light intensity, wind speeds, humidity, all that kind of stuff that's not living. And you might use the keyword biotic to describe the living factors like animals. Producers, they are important because they are the start of the food web. They use photosynthesis to produce to fix carbon dioxide to make glucose using energy from the sun. Some of these sugars are used in respiration, which is a loss out of the organism, but the rest of that is used in their biomass of a molecule. So this can be found in stuff like cellulose. Yeah, that makes up the biomass. So we have ways to measure the biomass. It can be measured as carbon that an organism has inside of it, or it can be used as the dry mass of tissue per unit area. Water content varies in a living organism, which is why we don't use it to measure biomass. Instead, we use dry mass to measure biomass. So the way we do this is we put the organism in an oven, we heat it so that the water evaporates from the organism, and we weigh it every day until the organism is at a constant mass. And that is just the mass of the organism without any of the water in it, aka the dry mass. For the unit of biomass, it changes throughout a year, so it changes over time. Therefore, the units are kilograms per meters to the -2, years to the -1. There's a couple of equations you need to know to calculate this. There's one for primary producers, and then there's secondary consumers, all that kind of stuff. So there's this thing NPP, and NPP is the net primary productivity. And to work this out, you need the GPP, which is the gross primary productivity, minus R, which is respiration. GPP is the production, the total amount of chemical energy converted from light energy. This is in a plant, specifically a plant. And because we lose some of that energy as respiration, that means that that is not included in NPP. So we take it away from GPP to make NPP. The remaining chemical energy is NPP. So that is once you've taken away respiration as a factor. So NPP is the energy available for the plant to grow, but it is also the energy available for the next trophic level. So if it's grass and its NPP is 12 kilojoules per mole, all that kind of stuff, then the rabbit that eats the grass will take in that number of NPP. And then all sorts of different things happen, but we'll get into that a bit later. So you have net production in consumers. So we've covered plants, which are producers. Now we have to cover what eats them. So this equation is N, which is production available to next level. So if it was a rabbit, this would be the fox. That's what would be available to it. N equals I, which is energy in ingested food, minus, and then in brackets, F, which is energy lost in feces and urine, plus energy lost in respiration. So we're adding up all the ways that the energy can be lost in a consumer, and we are taking it away from the energy it took in from the thing it consumed in the previous trophic level. That gives you N. And I've kind of mentioned this, but the energy losses, there's kind of a couple that you need to know. Around 90% of the total available energy is lost in various ways. That's a lot of energy. So when you do maths questions on this kind of topic and you get a really low number for what's passed on, don't be surprised, don't think that's like wrong. It's probably right because a lot of that energy is lost in different ways. Not all the energy is absorbed. So you have light and you have a plant. And light is everywhere and plant is just in one place. So if I was to throw a ball, which is the light, I throw it, it misses a lot of the time my finger, which is plant. I don't know why I'm using this thing. It doesn't really make sense to anyone, but if it does, that's good. So some of the light energy misses the plant completely. Obviously, that cannot be absorbed and cannot be incorporated into the plant, so it is therefore lost. Um, Also with light, some of it is of the wrong wavelength, like green, because plants, like leaves, chlorophyll, they was it reflects green. I could be very wrong. Let me just check that. Ooh. I'm correct. They do absorb green after further evaluation from Google. Uh, and we can measure the energy in an organism using bomb calorimetry. And if you do chemistry, this should probably be pretty familiar to you. I do chemistry and I plan to do more videos on chemistry, despite not being that good at it because I need to actually revise it. So we use bomb calorimetry. The point of it is to measure the heat energy released from burning the biomass, and that energy released from burning the biomass is used to heat a known volume of water. The change in water temperature is used to calculate the chemical energy. So there's a couple features of a bomb calorimeter that makes it so that the energy isn't lost to the surroundings and it's spread out properly. So for it to not be lost to surroundings, it needs to be completely encased in water and completely insulated. So none of that energy can go anywhere else and it's only heating the water. And we use a mechanized stirrer to make sure all the heat is spread out throughout the water because it's kind of useless to assume that because the water right next to the place that's burning is hot, the rest of it's hot and therefore all of it's been heated, which it hasn't. That's why we use a motorized stirrer to make sure everything's warm and we can collect the proper data. We have a thermometer for obvious reasons to measure the temperature, so that's in there. And if you need any more like detailed notes, I recommend if you do just biology, not chemistry, to take a look at some AQA chemistry notes on the bomb calorimeter. It might be in more depth than you are probably looking for or used to, but it can definitely help to be in that more detail because a lot of the students you will be coming up against in the actual exam probably do chemistry if they do biology. So knowing that extra detail might help in that kind of sense. But don't take my word for it. Revise however you want. I'm just here to explain mainly to myself, but also to other people who might watch this. So the units of productivity. There's a couple, but they're the same for both primary and secondary production. Um, Gross primary slash secondary production, because they're the same unit, is kilojoules per m to the minus 2. Obviously, I'm not gonna like edit photos into the side. Maybe I will, but I don't know how to do that. So if they do appear there, just know I've learned and because I learned. It's my first time actually recording a YouTube video that I plan to post. Um, Primary productivity. Did I say? Okay, wait. I'm gonna redo that. Gross primary slash secondary production is kilojoules 2. M to the minus 2. I think M is mass. Just think about that. And primary / secondary productivity is kilojoules, M to minus 2, yeah, minus 1, because they change over time. And then, so a little tip I've got, a little thing that works in my mind, is when I see these units and it has a minus 2 on the bottom, I imagine them as fractions. If it has a minus 2, it's on the bottom of the fraction. So kilojoules per mole minus 2 would mean that it is kilojoules divided by moles squared? Not moles, mass squared. If I've been saying moles, I deeply apologize. I mean mass. Um, efficiency of energy transfer. This is where it all comes in and all links, and this is an important equation. Probably put it up on the screen. Hopefully, I'll put it up on the screen. I apologize for the camera quality. I don't know why I'm mentioning this now, but I apologize for it. This is my laptop and it is not made for recording. Efficiency of energy transfer is the percentage. It's a percentage, so we times it by 100. The net production of a trophy level divided by the net production of the previous trophic level. So yeah, if I was to use an analogy, it would be the NPP of grass divided by the N of, wait, no, the N of the rabbit divided by the NPP of grass times by 100 to make it a percentage. And as you move up the food chain from producers to consumers, transfer is usually more efficient. This is because plants contain more inedible matter of things that rabbits and stuff don't eat. Like we usually wouldn't eat the roots of a plant. We usually eat the thing on top. And rabbits usually wouldn't eat the bark of trees. So it's definitely lost in the like transfer of energy because they can't take in all the energy of the plant. And you can consume more of an animal than you can of a plant, so therefore it is just checking if I haven't paused it on accident. Anyway, this is the sheet I've been using for this video. I made it this morning. That's why I'm kind of like not really good at explaining it. Obviously, you can't really see it because of how bad this freaking camera quality is, but I'll take a picture of it and then put it up here. I have a cute little drawing there. Just it's what I do to fill in space. I recommend it for you guys. It makes the stuff more memorable for me. Like if I'm revising, I want my revision notes to be more memorable. Also, it helps me know where they are, how to remember. And then, cute little thing I do, right? I make treasury tags. I crochet treasury tags because I cannot be bothered going out to the shop and getting one. I know it would take me 5 minutes, but I feel like these are cute. I made a cat today just to put these together. This is aromatic compounds, so we can ignore this. I'm not going to put that beside a screen. I might do a different video on that, but right now, no. There we go. Hope you enjoyed this video. I hope it was maybe helpful. If you watched this to the end, I commend you. I really do because I'm terrible at explaining things. I will post more. I don't expect you to come back. If you want to subscribe, by all means. Probably not gonna upload anything past A-level exams because so the subjects I do are geography, chemistry, and biology. So I might upload things for them. Though the exam board I follow for biology and chemistry is AQA, and the exam board I follow for geography is Excel. Unfortunately, I don't think many people do geography in the first place or at Excel. So the niche community, I'm capping into that. Bye.